Okay. Assalamualaikum warahmatullahi wabarakatuh, and hi, my name is Muhammad Iskandar bin Naziri, CE180105. Today I would like to present about the final year project 2. So my project is about the transmission efficiency analysis of the different patch antenna design, configuration in various distance for wireless power transfer. So my supervisor is Dr. Elfa Rizani binti Baharudin. She is a lecturer, and also she is my supervisor, PSM Group 2. For introduction for the projects is about the wireless power transfer. Wireless power transfer is gaining popularity used in the charging of a portable electronic device, which is a phone, laptop, and so on. Wireless power transfer has a proof in the experiment, which is using evanescence resonance sampling approach using coil. So that's use old version technology. But this era, that wireless power transfer has improved, which is by using microwave power transfer (MPT) system, which is the direct current is converted into the microwave radiation, and it is sent from the transmitter antenna to the reception antenna. So the problem statement is about two, which is the antenna configuration. There are a lot of the type of the antenna to do not to use for the wireless power transfer. So, the antenna design configuration is changed. The antenna characteristic parameter will also be changed. So it depends of the performance. The performance of an antenna is depend of the characteristic of the antenna. The second one is a distance in transmitting. As we know, that transmitting the electromagnetic wave process will give a low efficiency at a further distance. So we need to transmit an optimal efficiency at a longer distance. And the wireless phone transfer is always big challenging in the term of to transfer the power at a very distance. So the aim of the objective, there are three. We need to design the several antenna configuration at around about 900 MHz and for the wireless phone transfer. Second, we need to analyze the wireless power transfer power transmission efficiency at a very distance between 1 centimeter to the 12 centimeter. And the last one, we need to analyze the microstrip antenna performed in the term of the characteristic antenna, which is the S1, power transmission efficiency, the return loss, the VSW, and so on. Next up is about the literature review. There are three the study reference. The first one is analysis of on the transfer efficiency of a gift of the 5 different antenna configuration in short distance wireless power transfer. These are the thesis. They are that have a lot of the antenna, but I choose for two the performance of an antenna, the good performance antenna, which is a circle patch antenna with lump port and inductor, and the square patch antenna with lump port and inductor. Both antenna use a same operating at 900 MHz, and then the between of the antenna transmitter and receiver antenna is around about 1 centimeter into the transfer 12 centimeter. For return loss for the circle patch antenna is around about negative 14 dB, and the efficiency, the power transmission efficiency is around about negative 11. So the second one is about the square patch antenna. The return loss of the returns of the square patch antenna is around about negative 11.8 dB. For the power transmission efficiency is around about negative 11.2 dB. The second reference is about the design of the microsurface antenna at a 900 MHz for the charging mobile application. So this thesis is using a square patch antenna and operating around about 900 MHz, and the distance of the between the antenna is around about 1 centimeter to 100 centimeter, and then the return loss is about around about negative 14.70 dB, and the power efficiency, power transmission efficiency is doesn't show up in the this thesis. The last one is about optimal design of the wireless power transfer system using microscope patch antenna array. So this is use 4 times 4 patch array antenna. The operation frequency is around about 5.8 gigahertz, and the return loss is negative 23 dB, and the power transmission efficiency is a stay above a negative dB. They are show up the distance of the both antenna in this thesis. Next up is about the methodology. There are the four process, which is we need to study project background and the lecture review. After we study, we need to design several antenna, and then we simulate the between both antenna in distance 1 centimeter to 12 centimeter. And the last one, we need to analyze and compare the power transmission efficiency each of the antenna design. So in the first one, we need to choose the type of antenna suitable for this work. So we choose a patch antenna. The material for design the patch antenna, we use a FR4 material. The thinness height of the FR4 is 1.6 millimeter, and the dielectric constant is 4.3. So after we have all the material, we need to manual calculate the method for design the patch antenna. In the phase 2, when the manual calculation for dimension of antenna is done, all the parameter we apply to the software, which is we use CST Studio to design and simulate antenna. After we simulate, we optimize the parameter of the antenna, and then we check out the characteristic of the antenna. Is it the mid antenna simulate at the 900 megahertz, which is the return loss, the VSWR, and so on. If the not perform of the characteristic antenna, we need to redesign it, redesign and simulate antenna, and then we optimize the parameter of an antenna, and then check out the characteristic of the antenna. Is it perform or not? And then if it perform, we go to phase 3. Phase 3, if it perform, we need to set up distance in 1 centimeter to 12 centimeter. After we set up and we simulate, and then we look at the S21, which is the power transmission efficiency. Is it the value, or is it the antenna is higher than the negative 11 dB in the range of the 1 centimeter to 12 centimeter? If not perform, we'll be redesigning and simulate at the antenna and set up the distance in 1 centimeter to 12 centimeter. And then we simulate, is it the S21 is over negative 11 dB? Is it perform? Will be analyze the power transmission efficiency each of the antenna. So in this part, I have designed a tree of patch antenna. One is a square microstrip patch antenna with inside. So this is the antenna. Second is a rectangular microstrip patch antenna with inside. So this is an antenna, rectangular microstrip patch. And the last one is a square microstrip patch antenna with slot. So this is antenna, square patch antenna with slot. When we do how to set up the for wireless power transfer. First, we need to set up between two antenna at the distance ranging from 1 centimeter to 12 centimeter. And then we simulate the antenna operating at 900 megahertz, and then the receiver antenna will be the receiver antenna parameter design was used the same as value parameter design for transmitter antenna. So they just copy paste from the parameter of the transmitter to be the receiver, to be a receiver antenna. Now I will show up the demo simulation to set up it. First, we need to design the antenna. After we design our antenna, we start the simulation, and then after the simulation, we check up the characteristic of this antenna. Is it a good perform or not? So first we need to check up the S parameter S11. Make sure that the S11 is the resonant frequency is at the 900 megahertz, and then we need to check up, make sure that the resonant frequency is below of the negative 10 dB. Negative 10 dB. So if below the negative 10 dB is means that the good performance of the characteristic antenna, and then we know that has to be SWR. The FSWR need to below of a 2 at the 900 megahertz. So this one. So the value is 1.026. So this show that it's a below of 2 is means that it show there's a good this antenna is a perform. So after that we know that the characteristic and antenna is a perform, we need to set up the antenna to wireless power transfer. First we need to go to component, and then copy paste this antenna, copy, and then we paste this one. We copy as copy this antenna as for the receiver antenna, and then we adjust it, adjust for transform, and then 1 for this, for conversion to distance of the between antenna and receiver. So when I apply, will be start the receiver will be go to in front. So we rotate the antenna in around about 180 degrees, and then we okay, and then we check out the distance of the both antenna. So both antenna we go to view, and then dimension, start with dimension here to here, and then we know that the dimension the distance is around about 120 millimeter, which means in around about 12 centimeter. And then after we simulate, after we did the design, after we set up the between 1 centimeter to 12 centimeter, we need to set up start simulation to know the power transmission efficiency, which is a S21. So after we simulate, after we simulate the antenna, we go to the S21 to know the efficiency, power transmission efficiency. So for around about negative in around about 12 centimeter, the efficiency, the power transmission efficiency is around about negative 40.18. So this means that the around in the range of 1 centimeter until 12 centimeter is not performed because it is below of the negative 11 dB. So we need to redesign it and simulate again to find to get the good performance above from the negative 11 dB. Next time we talk about the result and the discussion. So this part we talk about the characteristic of antenna, each of the antenna. So For this part, we talk about the little loss. Each antenna has a below is a below negative 10 for the little loss. So for the square microstrip patch antenna, the S11 is a negative 19.763 dB at the 900 megahertz. For the rectangular microstrip, the S11 is a negative 43.18 dB at the 900 megahertz, and the last one is the square microstrip patch antenna with slot. Is the S11 is negative 37.7 dB at the 900 megahertz. Next up is about VSWR. As we know, all the result VSWR from the each of the antenna design is below of 2. For square microstrip, the VSWR is 1.2. For rectangular microstrip is 1.04, 1.01, and the last one for the square microstrip patch antenna with slot is 1.026. Next up is about the bandwidth. The square microstrip patch antenna with the insert. The bandwidth is around about 23.361 megahertz. The rectangular microstrip patch antenna, the bandwidth is around about 29.9 to 4 megahertz. And the last one for the square microstrip patch antenna with slot is 24.94 megahertz. Now we start analyze the power transmission efficiency from the each of the antenna. So the blue line is a square patch with insert. The orange one is a rectangular patch with insert, and the last one is a square patch with its slot. Okay, for this part, we need to discuss how discuss the distance from the 1 centimeter to 50 centimeter to find the value of the. Okay. In this part, we talk about the distance for the 1 centimeter to. For this part, we need to talk about the analysis result and discussion. And then for this, we simulate the distance from the 1 centimeter to 50 centimeter. And then we need has a minimum distance and a maximum distance. The minimum is a 3 centimeter and maximum is a 50 centimeter. For the square microstrip patch antenna, the minimum is around about 23.28%, and the maximum is distance is around about 2.837 percent for the power transmission efficiency. However, the rectangular microstrip patch antenna, when the minimum is 3 centimeter, the power transmission efficiency is around about 29.51%, and the maximum is a 2.64 2.64% percent. The last one is a square microstrip patch antenna with slot. When in the 3 centimeter, the power transmission efficiency is around about 25.10%, and when the maximum distance, the power transmission efficiency is around about 1.97%. The okay, based on the this result, as we know, when the receiver antenna near from the transmitter, the power transmission efficiency will increase. So when the receiver antenna far away from the transmitter, the power transmission efficiency will decrease. So the best and the highest of the power transmission efficiency is the rectangular microstrip patch antenna with insert, because the when the distance in a 3 centimeter, the power transmission efficiency is a bigger than the others this other antenna, which means it's a more than the other antenna. when the lowest result value of the power transmission efficiency is a square microsweep patch antenna with slot, because when the far away around about 50 centimeter, the power transmission efficiency is about around about 1.97%. It's lower than the others antenna. In conclusion, the basic idea and knowledge of the antenna must be grasped because the character and performance of the patch antenna is depend on the parameter design. For after we simulate the transmitter and receiver antenna at the very distant between 1 centimeter to 20 centimeter, we must be check up the characteristic of the antenna was performed. Is it the reticulus is performed? Is it the VSLW performed or the characteristic and so on? Make sure that the characteristic of antenna must be performed. And then the last one, the result of the transmission efficiency performance from each antenna design was comparison, which is from a three design of an antenna, the rectangular micropatch antenna with the insert is better than other antenna. So that's all.